Okay, our example, the height, S of t in feet. That sounds important. The height, S and t in feet, of a ball thrown upward at an initial speed of 80 feet per second from a platform 15 feet high is given by the function S of t equals negative 16t to the second power plus 80t plus 50, where t is the time in seconds. I underlined the height S of t because that's our function. I ignored some of these other numbers because I don't know if they're important yet. And I found that the function that actually has those numbers, that function is written out with this equation, but t is also defined here. You don't have to graph it, but I just want to show you what the graph would look like so you have a picture in your head. Time is the x-axis, or the independent variable, goodness. And height is the dependent variable, or the y-axis, because it depends on the time. So the height changes depending on the time, and at some point there will be a maximum. So that was just to show you. I'm going to erase it now and switch to the equation. So the equation, so this is a quadratic equation because it has this t squared in it to the second power. And what we're going to do is we're going to find the maximum height above the ground. The maximum height is the vertex. I was showing you why that is. It has a maximum height, and so we're going to actually find it. And we're going to do that by finding the vertex x coordinate first, which is using the formula negative b over 2a, where 2a is all together. You got to do 2 times a together, which is why I put the parentheses. But the thing is, we need to know what the heck I mean by a, b, and c. So those are the coefficient, the numbers in front of the variables in the original equation. We have a is negative 16. B is positive 80. There's no t, it's just positive 80. And C is plus 50. So again, the t's that are there are variables, the independent variable that does not need to enter into the vertex equation. Those we're going to use later. So it's time to plug in to the vertex equation these actual things. So x equals negative b, which we're going to put in, over 2 multiplied by a, which we're going to put in. So we need to put in, oops, it was this color. We need to put in negative 16. And we need to put in, that does not look like 16, sorry. And we need to put in positive, no, what did I just do? I made a mistake. I need to go back. We need to put in 80 because that's B, not A. Watch out for that mistake. And we need to put in negative 16 because that's A. Watch out. Make sure you don't make that mistake. Put the B in the right spot. That was 80. That goes here. Whereas the negative 16 is on the bottom. So we could just type the whole thing into the calculator. Negative 80 divided by parentheses 2 times negative 16. If you do both negatives correctly, you will get a positive result in this case. And so our answer is a positive 2.5. That is the x-coordinate of the vertex. Now we're going to need to find the y-coordinate because the maximum height is the actual y. The height is the S of t, or the output of using this input of 2.5. So now we have new information. 2.5 seconds is when the ball is at the maximum height. But the actual maximum height we still have to do. So remember when I used, let's choose one more color. Remember when I was talking about the variables up here? These variables are based on the time in seconds. So, in other words, S of t now is going to be S of 2.5 specifically. We're going to plug in 2.5 everywhere that we had T before. Everywhere that we had T before, that's where we're going to plug in 2.5. So I've got my purple 2.5. No, I don't. Okay, now I do. We've got my purple 2.5. We're plugging it in everywhere. And we're actually calculating this part out to get an answer of what the maximum height is. So we can do each part. Again, in a calculator is fine. You can do it all together if you want. If you do it in parts, the first part will be negative 100. Don't forget, it's negative 16 times 2.5 squared. The 2.5 squared is together. The 16 does not combine with the 2 until after, with the 2.5 until after. Okay, 80 times 2.5 and 50. We add them all up. We get 150. So the original question was, what is the maximum height above the ground that the ball will attain? Find the maximum height. Okay, we just did. We found that it was 150, so we need to write a final answer. The maximum height. That's not a B. The maximum height is 150 feet. Or any other combination of that sentence. So in your actual classwork, I break down these steps and these questions into parts so that it can help you proceed. But in the end, each part combines to give you this final answer. The maximum height is 150 feet.